Hello everyone and welcome to this introduction to remote sensing. My name is Sofia Peleli and in this video we will explore the fascinating world of remote sensing, how we use satellite and aerial data to observe and analyze the Earth's surface. Whether you are new to the field or looking to deepen your understanding, we will cover the fundamental concepts, some key applications, and the role of remote sensing in environmental monitoring, disaster management, and beyond. This video is brought to you by Jassour, where knowledge is bridged with innovation. So let's dive in and uncover the power of remote sensing. But first, let me introduce myself. I was born and raised in Athens, and for the past 15 years, I have lived in Chania in Crete Island. I am a GIS and remote sensing expert at Technical Development Solutions, and at the same time, I am a PhD candidate in remote sensing at the Hellenic Mediterranean University, specializing in satellite based earthquake prediction through multi-parametric analysis. So let's see the topics that will be covered in this introduction. We will try to answer questions such as what comes to mind when we hear the term satellite images? Is it possible to study changes and the quality of vegetation, water, urban environment, climate, and natural disasters from space? Did you know that satellites measure things that we can't see with our eyes, such as temperature, gas emissions, tiny surface cracks, or moisture levels? Can satellite images help us uncover the ancient world and predict the future? And why a satellite image is different from a photograph? So, what is the definition of remote sensing? There are a lot of definitions, but the one I prefer is that remote sensing or Earth observational systems refers to the ability to study or collect information for an object or a phenomenon from a distance without a physical contact. And I will begin with an exercise to understand simply the difference of a satellite image and a photograph. What do you think that we see in these two pictures? Clouds or snow? The left image is in Antarctica and the right image is in the north of USA. I will guess that most of you answered snow. What about this image? We know it is in Philippines, and what we also know about Philippines is that it never snows. So let's see. I guess most of you answered clouds. And what about this image now? We do not know the location of this image. Do we see clouds or snow? Let's take a moment to think about it. If we were in a classroom together, I will bet that most of you would start fighting between if it is snow or cloud, or maybe both of them. With a photograph, it is almost impossible to understand, and especially if we don't know the area and the epoch. But with a satellite image, after we analyze it, we can know what it is. And here is an example. On the left side, you see the grayscale image where you don't know what is snow and what is clouds. But after processing and analyzing and making the statistical analysis to the satellite image, we get the right one. And we can see that the light blue refers to snow, the red to clouds, and the orange or yellow to transparent clouds. So let's take a look at this important difference. When we take a regular photograph with a camera, we are capturing only the visible light spectrum, what our eyes can naturally see. This is just a tiny part of the electromagnetic spectrum. Satellites, on the other hand, have the ability to detect a much broader range. They can capture data from the infrared, the microwave, the optical, and the ultraviolet parts of the spectrum, allowing us to see beyond what's visible to the human eye. This capability is what makes remote sensing so powerful. It helps us analyze changes in vegetation, detect water quality, monitor land use, and even study climate patterns from space. So let's see the structured process that remote sensing follows, where energy interacts with objects on Earth and is captured by sensors. The source of energy can be the sun or an active sensor that emits its own signal. The energy reaches the study area, where objects absorb, reflect, or transmit it differently. A sensor, which can be a satellite, an aircraft, or drone, captures this information and sends it to a receiving station for processing. By analyzing this data, we can extract valuable insights about the environment, land use, and many other applications. Remote sensing is being used in over 100 applications, but here I have just presented some of the major ones. And those ones are geosciences, with geology, hydrogeology, hydrology, and natural disasters management, agriculture, urban planning, archaeology, climate sciences, social sciences, and medical sciences. But let's be clear on something. Can remote sensing replace other scientific fields? This is a very common question from other specialities. The answer is no, or at least in most of the cases, no. Because while remote sensing has been proven to provide highly accurate results in many cases compared to traditional scientific methods, the calibration and validation through in situ experiments remain essential. Then why choose remote sensing? Because it offers several advantages, and some of them are cost effectiveness. Many datasets are available for free or at a very low cost, especially compared to the in situ measurements. Access to remote areas. With satellite images, we are able to study locations that are difficult or impossible to reach. Continuous monitoring provides frequent and consistent data over time. We have the ability to study satellite images that have been captured daily or even every 5 or 10 minutes. Weather independence. Depending on the application, some sensors, such as radar, can operate in all weather conditions, and convenience of selecting different scales. Remote sensing is a powerful tool with a wide range of applications, and here are some key examples. Land deformation detection after a seismic event, thermal anomalies monitoring before, during, and after earthquakes, high-resolution 3D mapping of forests showing tree height and health conditions, urban change detection tracking how cities evolve over time, dust storm movement monitoring in the Middle East, improving weather predictions. Even augmented reality applications like Pokemon Go rely on remote sensing technology, digital elevation models that allows us to analyze terrain and elevation. In conclusion, remote sensing allows us to see the unseen, from the depths of Earth's core to the vastness of space, and from ancient history to future predictions. By selecting the right sensors, applying the proper analysis, and asking the right questions, we can uncover the past, monitor the present, and even predict changes in the future. Whether studying archaeological sites, underground structures, planetary exploration, or environmental changes, remote sensing continues to expand our understanding of the world and beyond. If you are interested in learning more about remote sensing or exploring GIS applications for analyzing satellite images, stay tuned. More videos will be uploaded soon on Jassour. For any questions, feel free to reach out by sending an email to Jassour. Thank you for watching.